Hi, in this video, we're going to learn how to use if-else statements inside our programs. Let's get started. As a refresher, an if-else statement is a control structure that can be used to direct our programs when it is met with a decision. If-else statements are extremely helpful in physical computing programs because our devices are constantly receiving information about their environment through sensors, and we can use if-else statements to give them directions based on the values they find. If statements work a bit differently depending on the way we define them. If we define multiple if statements one after another, our program will check each one individually and perform actions based on each condition. If we instead use an if-else structure, our program will check the conditions starting from the top, and once it finds one that is true, it will perform those actions and skip the rest of the statements. To write an if-else statement, we use this syntax. Let's explain this a bit. We start our statement with the if keyword. Inside parentheses, we write a condition. Indented below, inside curly braces, we write the commands to run if the above condition is true. Any additional conditions we have can be written inside else if statements. This means that this condition will only be checked if the above condition evaluates to false. We can add as many conditions as we want this way. Our final statement in an if-else statement is an else block, where no condition is named. This is because this block will only run if all the above conditions have evaluated to false. Note that else if and else blocks are optional. Let's take a look at an example. In this example, there are 3 scenarios that will run different commands based on the value of the buttons. The first condition is checking if button A is pressed. If it is, the center LED will be lit at full brightness. The second condition is checking if button B is pressed. If it is, the center LED will be lit at half brightness. In any other scenario, the center LED will be turned off. So what would happen if we ran the program and pressed button A? Well, the center LED would be turned on at full brightness until the button was released. What would happen if we ran the program and pressed button B? The center LED would be turned on at half brightness until the button was released. If we ran the program and no button was pressed, no LEDs would be lit on the screen. During your next exploration, you'll be using a new component, a servo motor. This motor uses a feedback system to control position. Many servo motors can be set to positions from 0 to 180. You'll explore more about this functionality in the next exercise, but it is important to note that the wires on a servo motor are color-coded, either using brown, red, and orange wires or black, red, and white wires. The brown or black wire is always connected to ground, the red wire is connected to power, and the orange or white wire is connected to a pin. In MakeCode, the servo will automatically connect in your simulation when you use the servo commands. The wires coming from the servo are color-coded as we expect, but the connecting wires change color to purple and blue in our simulation. One thing to note is that the 3 volts of power coming from our microbit is not enough to run a servo motor on its own, so we'll need to connect an external battery to power the servo. Let's take a quick look at some important tips when using an external power source. An external battery pack will be used to provide additional power to specific components in our circuit. In this case, it will power a servo motor. We never want to connect an external power source directly to our microbit device. It will only connect to the component it is powering. If it is incorrectly connected to the microbit, it can damage the device. To be sure that your circuit is correctly wired without doing any damage, it is a good idea to connect an empty battery pack first and have your teacher check your circuit before adding batteries. Let's dissect the circuit we'll build in the upcoming exploration. The microbit pin, either 0, 1, or 2, will be connected to the orange servo wire. The 3-volt pin will be empty. Nothing should be connected here. The ground pin will have 2 connections, one to the brown wire of the servo motor and the other to the black wire of the battery pack. The red wire of the external battery pack will be directly connected to the red wire of the servo motor. You may want to revisit this slide when connecting your circuit in the next activity. In this lesson, we learned how to use if and if-else statements inside our programs. Now it's your turn to explore these statements in your own microbit programs.